Okay. So now I will continue with this slide, the same slide, white fibrocartilage. So in white fibrocartilage, what we see here are the fibers, the collagen fibers, and then in between the collagen fibers, you can see the chondrocytes which are present as the single cells, not in groups. So these will appear like arranged like string of pearls in between the collagen fibers, like a string of pearls. So like this, you can see the in between the collagen fibers. So that's about the white fibrocartilage. So the identifying features for the white fibrocartilage are, so you don't see the perichondrium, you absent perichondrium, and you see the thick bundles of fibers, collagen fibers, and then in between the collagen fibers you see the chondrocytes in the lacunae, individual chondrocytes in the lacunae. That is the identification feature for the white fibrocartilage. And where do you see this white fibrocartilage? So this white fibrocartilage is present at the areas where you see the sites, the bones which are developed in the membranous ossification. For example, if you see the temporomandibular joint, the TM joint, so in the TM joint, the surfaces are covered by the white fibrocartilage. So when we see, look at the bones, the long bones, they are covered, the ends of the long bones are covered by the hyaline cartilage. But here, by the TM joint, the surfaces are lined by the white fibrocartilage, and in the articular disc. So wherever you see the articular disc in the joints, so in the TM joint, sternoclavicular joint, acromioclavicular joint, these are the areas where you see the articular disc. So in those articular discs, these articular discs are also made up of the white fibrocartilage. And the menisci, so you see in the knee joint where you see the menisci, medial and lateral menisci, these are also made up of the white fibrocartilage. These are the areas where you see, some of the areas where you see the white fibrocartilage. So next, coming to the other type of connective tissue, that is the bone. So in bone we have two sections, the longitudinal section, LS means longitudinal section, TS means transverse section. So here these two bone slides which we are seeing, these are the compact bone, not the cancellous bone. So this is compact bone. So where do you see the compact bone? So at the ends of the long, so here at the peripheries of the long bones, the sides of the long bones, you see the compact bone. In the center part of the long bone, you see the cancellous bone. But here at the peripheral part of the long bones, you see the compact bone. So this compact bone is made up of the structural and the functional unit of any bone is the osteon. So you see the osteon. So what is an osteon? So osteon is so this is seen around the Haversian system. So there are a number of canals like structures within the bone, within this compact bone. So these canals are called the Haversian canals. These are the ones which carry the blood vessels, lymphatic vessels, and the connective tissue. So this Haversian canals, around the Haversian canals, you see the bony structure as in the form of the concentric layers. So you see the concentric layers of the bony matrix, and this matrix, within these bony matrix, trapped between these layers of the ground substance, you see the osteocytes which are present in the lacunae. So around these, so within these concentric layers of the bony matrix, you see the osteocytes in the lacunae. So these lacunae are called the Hausmann ships. So these are the lacunae. Within these lacunae, so you see the osteocytes, and these, so you see another the layer of the matrix here, and in between, so how these or the osteocytes are connected with each other. So these will be by means of the canaliculi. So you see number of canaliculi like this, and these canaliculi, through these canaliculi, you see the cytoplasmic processes which will extend along these canaliculi. So each cell will have like this processes which are cytoplasmic processes which are extending, and through these canaliculae, so the nutrients from these the one lacunae to the other lacunae will diffuse. So that is the function of this canaliculae. So you see these, so if you take the transverse section, you see these like this. So concentric layers of osteocytes in between the matrix. In the center you see the Haversian canal. But if you take this as a longitudinal section, so you see the Haversian canals as a longitudinal structures, and two Haversian systems, two canals are connected by means of a Walkman's canal. So these two canals are connected by means of a Walkman's canal. And so if you take the transverse section of this, so you can see another osteon like this, and in the center you see the Haversian canal. These two are connected by means of the Walkman's canal. So if you see here the bone slide, this is the longitudinal section of a bone, and here you are not seeing any stain here because this is unstained sections. That means other slides you see with the pink and the purple color, because we use the eosin and hematoxylin stain. Here these bone slides you can easily identify. No one should make any mistake in this identification of the bone section, bone slides LS and TS, because these are unstained sections. So easily you can identify these bone slides. Because so when we decalcify the bony tissue, then we will directly make them into sections. We don't use any stains, but we can use the stains, the special stains or eosin and hematoxylin stains can be used to stain the bone. But whatever the slides you have for exams, they are unstained slides. So here you can see this is the longitudinal section. How do you identify the longitudinal section of a bone? Longitudinal section of a bone you can identify by means of the longitudinally placed Haversian canal. So this is the Haversian canal, and then you can see extending, connecting these Haversian canals. So you see this is one Haversian canal here, and this is another Haversian canal here, and these are connected here by means of a side canals. These are the Walkman's canals, and in between these canals you can see here. So when you take the transverse section, this will be concentric layers, but when you take the longitudinal section, you will get the longitudinal section of the osteon. So where you can see here the lamellae. So in the longitudinal, so these lamellae are also arranged in the longitudinal fashion, and then in between these lamellae you see the lacunae with the osteocytes. So osteocytes you can't see here. This is the dried bone, so you don't see any osteocytes in these canaliculae, and in this the lacunae here. So these dark ones here, what you are seeing, all these are the lacunae with the osteocytes. So that's about the longitudinal section of the bone, and this is the transverse section of the bone. So here the transverse section of the bone, you see the osteon. So the transverse section of an osteon, and in the center of that, so this black one which you are seeing is the Haversian canal. So this is the dried bone. That's why you don't see any blood vessels or any cells in this. Only the skeleton framework you see here, and so that's the central one is the Haversian canal. Here also you can see one Haversian canal, and this is one osteon, this is another osteon. Sometimes you may see the oblique section here of the Haversian canal, and Walkman's canal I can't see here in this section, and here you can see that the surrounding this Haversian canal, clearly you can see the concentric lamellae. So you can see here, this is one lamellae, this is another lamellae. So you can see like an onion, when you cut the onion transversely, how you see the concentric layers of the leaves of the onion, like that you see here also the concentric layers of the matrix in the form of the surrounding osteon, and in between these lamellae, the concentric lamellae, you see the osteocytes which are trapped, and these will form like the within lacunae, and within the lacunae you see the osteocytes. myocytes, and these are connected to the adjacent cells through the lamellae by means of the canaliculate, so which help in the nutrition of the cells, so in the diffusion of the nutrients as well as the oxygen. So that's about the in between these lamellae, you see some of the lamellae which are not organized in the concentric layers. So these lamellae are called the interstitial lamellae. When we see the like a perichondrium, how we have seen, like that for the bone surrounding the covering the bone, you see the periosteum. So in this picture we don't get the periosteum in this slide, but you see the periosteum. So periosteum is also having two layers, outer fibrous layer and inner cellular layer, and beneath the periosteum you see the circumferential lamellae. So surrounding them you see the interstitial lamellae are the ones which are present in between the osteons, and then so surrounding that periosteum as well as the inner side, the medulla side, you see the inner and outer circumferential lamellae. So that's about the transverse section of the bone. And now, so you have only the TS and longitudinal section of the compact bone. It is the compact bone structure, and we are not keeping any slides of spongy bone or woven bone or the embryonic bone. So these are not there for your examination purpose. So this discussion is purely the exam oriented discussion, how to identify the slides, right? So that's about the bone slides. Now we'll move on to the next general anatomy slide, general histology slides. These are the muscle. So in the muscle you have two slides, is the skeletal muscle and the cardiac muscle slides. So skeletal muscle, before going into the slides, so you know that skeletal muscle fibers are so the fundamental difference between the skeletal and cardiac muscle. And another muscle, you have the smooth muscle. Smooth muscle you see in most of the slides of GIT and the reproductive system, the duct system and all. You see the smooth muscle which is arranged in concentric layers, in the circular layer as well as the longitudinal layers. So that we will discuss when we see the particular organ. And now here we discuss only the skeletal and the cardiac muscle. Smooth muscle we don't keep as a separate slide, but these two slides we keep as the spotter slides or the discussion slides for you in the exams. So first we see the skeletal muscle. So one point about the skeletal muscle is, so the skeletal muscle is a voluntary muscle. It has the striations. So when you take the section of the schematic diagram of the skeletal muscle, so it will have number of cross striations. Skeletal muscle striated. So you see the number of cross striations. These are because of the actin myosin filaments, the arrangement of the actin and myosin filaments. That is the one. Next point is the skeletal muscle fibers. These are the long fibers, and these are multinucleated. So they are not like single nucleated cells. So they are multinucleated cells. If you see the section, so if you see a muscle fiber, there sometimes you may see very long skeletal muscle fibers. At certain regions you see the short skeletal muscle fibers. For example, if you take the sartorius muscle, it is the one of the longest muscle in the body. So you see here the sartorius. So from its origin to insertion you see one fiber only, but for that much length of the fiber, so if you have one nucleus, it's very difficult to maintain the integrity of the cell. So you see number of nuclei and it is a multinucleated cell. So skeletal muscle fibers are multinucleated. They are not single nucleated. That is the first point you should remember. Then the second point is the cross striation. So when we take the longitudinal section, you see the cross striations. But when we take the transverse section of the muscle fibers, these actin myosin filaments are also cut. So because they are also cut, they will be seen like the granules. So in the cut granules, and the nuclei will be towards the periphery only. So here if you take the skeletal muscle fiber, the nuclei are not in the center, they are at the periphery. If you take this one fiber here, so you can see here these darkly stained structures are the nuclei of the skeletal muscle. So these are woven and these are present, at the periphery of the cell. So these are the nuclei. So if you see the center, at the center of the cells, so functionally it is irrelevant. So when you see the actin myosin filaments, so these may interfere with the function of the cell. So the nuclei is always pushed towards the periphery, and these are flattened nuclei. So you see the oval nuclei, longitudinally oval or the flattened nuclei at the peripheral part of the skeletal muscle fiber. So that's the structure of the skeletal muscle fibers. This is a skeletal muscle fiber consists of the striations. It is a striated muscle, and you see so these striations are because of the actin myosin filaments which are arranged in particular fashion. And then you see these are the multinucleated cells, and nuclei are situated at the peripheral part. And then, so here the skeletal muscle fibers, as a muscle, whole muscle is covered by the epimysium. Epimysium is nothing but the connective tissue that is covering the muscle. And then within this, so you see, if you take one muscle, so you see number of fibers like this in the single muscle, and these bundles of muscle fibers. So this is one bundle of fibers, and you see another bundle of fibers like that, and another bundle of fibers. So entire muscle is covered by the epimysium. Each bundle of fibers are covered by the perimysium. This is one bundle of fibers, this is another bundle of fibers, this is another bundle of fibers. So in between these bundles of fibers, you see the connective tissue. It's not very clear in this slide, but you see, so even if you have seen the gross anatomy, muscle, if you take the muscle, you can septize them into the individual fibers, bundles, and then the fibers. So each bundle of muscle fibers are covered by the perimysium, which is nothing but the collagen fibers and the blood vessels and all. And each fiber is covered by the endomysium. So each fiber is covered by the surface is covered by the endomysium. So that's about the structure of the skeletal muscle. So when you can easily identify the skeletal muscle fibers, by means we are keeping you only the longitudinal section of the skeletal muscle, not the transverse sections. In between these longitudinal bundles, you may get the transverse sections also or oblique sections, but mostly it is the longitudinal section. And you see the striations. In low power, it's difficult to identify the striations, but if you focus in high power, you can see the striations. But for the examination purpose and the spotter view, we keep only the low magnification, 10x magnification, and then that means 100x magnification. And in that you see only the nuclei you can identify, longitudinal bundles, and then you can identify the nuclei in between the bundles of fibers, and then these are multinucleated. So that's how you can identify the skeletal muscle. So you know the places where you see the skeletal muscle fibers, skeletal muscle, and so most of the muscles under voluntary control are the voluntary muscles are the skeletal muscles most of the time. So that's about the skeletal muscle. And then the cardiac muscle. So this cardiac muscle also consists of the striations, because these cardiac muscles also contains the actin and myosin filaments which are arranged in particular fashion. So you see the cross striations in the cardiac muscle, but in the smooth muscle you don't see the striations. So that's why they are called the smooth. So you don't see the striations, that's why they are smooth. So smooth muscle fibers do not have the striations, but the skeletal and the cardiac muscle have the striations. That is one point. And the second point is these individual fibers are the short fibers. So like unlike the skeletal muscle, which are the long fibers are seen, these are the short fibers. And then each fiber contain its own nucleus. These are uninuclear and centrally placed nucleus. But for the skeletal muscle, it is multinucleated and peripherally placed nucleus. So if you see the cardiac muscle, this is one cardiac muscle fiber and this is another cardiac muscle fiber. So these are connected with each other. So structurally they are individual cells, but functionally they act like a syncytium. That means all cells contract. So once the calcium wave sets in, so all the cardiac muscle fibers, they will be contracting in a single pace. So that's how you see the action of the heart. So and then this nucleus of these cells is placed in the center. So you see the centrally placed nucleus and perinuclear halo. So around the nucleus you see the clear zone. So for all these cells also you can see here around the nucleus, the cleared zone, this is called the perinuclear halo. And then because these peripheral part of these here you see the actin myosin filaments at the peripheral part of the cardiac cell, and the central part you don't see the actin and myosin filaments. That's why you see the around the nucleus you see the perinuclear halo. So these cardiac muscle fibers or single nucleus is present and which is centrally placed nucleus, and around the nucleus you see the perinuclear halo, and you see the cross striations because of the actin and myosin filaments, and adjacent to these cells, so in between these cells, so if you see another cell, cardiac muscle fiber cell, which are, so here you see the other cells which are presenting here, and then you see the cardiac cells. Between these cells at the lateral connections of the cardiac muscle fibers, you see the cell membrane is thickened and wavy, and that is called the intercalated disc. So you can see here as the cell membrane here, this is one intercalated disc, this is another intercalated. If you observe carefully, you see number of connections here which are thickly stained, and these are nothing but the intercellular connections. So junctional complexes, these will be appear as the thick ones on the eosin and hematoxylin stain, and these are called the intercalated disc. These intercalated discs are the identification feature for the cardiac muscle fibers. In your books all it is described as cardiac muscle fibers are branching, and you see the intercalated disc. Structurally, truly speaking, they are not branched fibers, but because of the cross connections with each cells, they appear as if they are branched. So they are described as the cardiac muscle fibers. They branch and anastomose with the other cells, but it is not the branching. So the cells, they have connections with the other cells like I described here. So these appear as if because of the intercalated disc, that cell lateral wall thickening of these cells, which we call it as the junctional complexes. Because of that they appear as the branched. But branched means these cells, if it is a cell, if it is branched like this, so if it has branches, this is the branching part, meaning, literal meaning of the branching, but you don't see like this in the structure. So these are truly speaking they are not branched, but they appear as if they are branched ones. That is the speciality of the cardiac muscle fibers. So they have cross connections, they have single centrally placed nucleus, and the intercalated disc are the identification feature for the cardiac muscle. And these cells, though they are individual cells, structurally, functionally they act like a syncytium, as a one cell. So that's about the cardiac muscle. And as bundles, so like epimysium, perimysium, this will be common for terminology is common. The bundles of fibers, entire muscle. So we call it like a perimysium, epimysium for the skeletal muscle, but for cardiac muscle, so entire heart is covered by the epicardium. So you see the covering of this cardiac muscle is the epicardium. So that's about the cardiac muscle. Now we'll see the nerve fiber, the last slide of the general histology. So this nerve fiber, we don't see the axons in this. Here we see the bundles of myelinated nerve fibers. So you can see here entire nerve is covered by the perineurium, epineurium, and each bundle of, so this is one bundle of nerve fibers, this is one bundle of nerve fibers. So individual bundles of nerve fibers, they are covered by the perineurium, and then each fiber is covered by the endoneurium. So epineurium, perineurium, and the endoneurium. So these are the terms which are used for the covering connective tissue fibers of these nerve fibers. And these nerve fibers are also seen in a different color, not like eosin and hematoxylin. This is because we use special stain to stain the nerve fibers, that is the osmic acid. So when we use the osmic acid, this are the silver stains, we get like black color. But we have the slides of eosin and hematoxylin stained slides of nerve fiber, but these are not kept for the examination purpose. But here we keep the peripheral nerve as the nerve fiber. And These color is because of these are all myelinated nerve fibers, so myelinated axons. So we don't see the cell body here in these slides, only the fiber structures you see here, and cell bodies are not no, present in this. So they are present in you all know that peripheral nerve, the cell bodies where they are present in the spinal cord, the gray matter of the spinal cord. Only the nerve fibers, they contain the these are the axons of the nerve, and then the bundles of the nerve fibers, so specially stained with the arsenic acid. This is also very easy and simple slide. You can easily identify the nerve fibers. So these are the general histology slides. So systemic histology slides we will discuss later. So I think you got the notice that your internal examination, because we did not because by the time you are supposed to write the second internal, it got postponed because of the lockdown. So we are conducting an internal exam. Most of you did not get good marks in the first internal. At least we should have some internal exam so that we can get your marks to update. For if the university asks, we need to upload your marks, so we need some exams to be conducted. So we may consider at the end these internal examinations as the final exams, because not final, sorry, to take them as the sum of the assignments and the internal exams, to get marks, to add marks for the internal marks. So we may consider these marks for the internal marks. And so please all of you write the internal examination tests, whatever that we are going to conduct in all the three subjects. I will post you the dates of the internal examination in your WhatsApp group. Otherwise, you might have get this notice from the college management itself, and try to write the exams, right? And those who did not pay fees, so as the management asks, you try to pay the fees on time and then write the internal exams. So thank you. And if you have any doubts, you can post your doubts in the group, so that we can clarify your doubts. And I have created one Google Classroom group, and I have added most of the students' email IDs. If anyone didn't get your email ID not added, just message me your email ID so that I can add to the group. And whatever that discussion or examination, tests or internal assessment, and examination schedules and doubts regarding the examinations, all those things, you can post your comments or queries in the Google Classroom group. Okay, thank you.